For the two-dimensional motion video analysis project, I analyzed a basketball moving in 2 dimensions. I also investigated how well our two-dimensional kinematics equations can describe the projectile motion of the basketball measured in real life. The equation that can be used to calculate the horizontal component of motion for an object moving in 2 dimensions is delta x equals Vx times delta t. Additionally, the horizontal component of the object's velocity is changing, and the horizontal component of the object's acceleration is 0. The equation that can be used to calculate the vertical component of motion for an object moving in 2 dimensions is the equation d equals Vyi times t plus 1/2 at squared. The vertical component of the object's velocity is constant. The vertical component of the object's acceleration is negative 9.8 meters per second squared. The shape of the path of position versus time of any projectile is an inverted parabola. The variables that determine the amount of time the object is in the air are the initial velocity in the vertical direction and gravity. With a greater vertical initial velocity, the object will move faster and will spend a shorter amount of time in the air. The gravity also affects the time the object is in the air because gravity pulls the object down and therefore results in the object staying in the air for a shorter period of time. The variables that determine the height and distance the object travels are the angle of launch, gravity, and the initial velocity. The steeper the angle the object is thrown at, the higher the object will go. Gravity affects the height by pulling it downwards and therefore affecting the maximum height and distance of the object. Lastly, with a greater initial velocity, the object will travel higher due to the greater initial vertical velocity and farther due to the greater initial horizontal velocity. The initial angle of launch affects the motion because, for example, with a steeper angle, the object will travel higher and have a greater height and vertical displacement and a smaller horizontal displacement. To collect data, first I collected all of the necessary materials, which were a yardstick, a recording device, a basketball, and a person to throw the basketball. Next, I laid the yardstick on the ground of where I was recording the video so I could use it as a scale while analyzing my results. Next, I had the person throwing the ball line up directly behind the yardstick. Then I took the recording device and made sure it was stationary, level, and perpendicular to the frame of motion. Then I instructed the person throwing the ball to throw it in the air in the shape of an inverted parabola and began recording the video. To analyze the data, I first imported the video into Logger Pro. I then defined the scale of the video with the yardstick in the frame. Next, I set up the graph so it would portray data of the motion for both the x and y variables. Then I paused the frame just as the ball was about to leave the person's hand and began to plot the points of the ball's motion. After that, I used the Analyze menu to assign a curve fit to the y variable and a linear fit to the x variable. Doing this also provided values that were used to determine the velocity and acceleration of the ball. I then used the quadratic equation to determine the acceleration and velocity of the ball as shown in the plot. The object that I chose to measure was a basketball being thrown into the air. The basketball moved higher as a result of a steeper angle of it being thrown at and faster depending on the force it was being thrown at. The basketball appeared to begin to slow down as it reached its maximum height, but then began to gain speed as it fell to the ground due to the height the ball reached and the gravity acting as a force on the ball. The shape of the motion of the ball was an inverted parabola. I also converted my measurements of feet to measurements of meters so they would be more easily comparable. These were the values of the motion of the ball. The horizontal velocity was about 3 meters per second, the vertical initial velocity was about 12.93 meters per second, and the acceleration due to gravity was about negative 4.69 meters per second squared. When comparing my results to outside sources, overall they seemed to make sense. First, I looked at how the horizontal component of motion was constant and compared it to an outside source. The source stated how the projectile will maintain a constant horizontal velocity, just as mine did. Also, I looked at my acceleration due to gravity, and it was expected to be about negative 4.9 meters per second squared, and mine was close to that, as it was around negative 4.7 meters per second squared.